Welcome back, everybody, to another exciting episode of the Physics Files, where today we'll see if Mr. Ryler messes up and is foiled by the forces of physics evil, or if he can prevail and get through another physics lecture. So let's dive in and see where we end up. Today we're going to talk about lenses and this is pretty cool. It's very similar to mirrors, and there's not a whole lot that's new, but there's a couple new things. What we're going to talk about today is first we're going to learn how a lens makes an image. We're going to learn about two different kinds of lenses. That's all you need to worry about, and we'll do a little bit of ray tracing for lenses. All right. Definitely going to need a straight edge and some colors today. Lots of big drawings. Remember, don't draw your lenses and lens diagrams small. Everybody seems to want to make them too little, and then it's hard to tell what's going on. So feel free to make nice big drawings. All right. Alrighty. So let's dive right in. Here we go. How do lenses make an image? First, we need to remember something. We need to remember Snell's law. Okay, and that was the thing where we had light going into a substance of a different index of refraction. Okay, so look at the left side here. If light comes in from the air into water, for example, and we have N1 being smaller than N2, what will happen is the ray bends, whoops, didn't mean to cross it out, I was trying to underline. The ray bends toward the perpendicular. Okay? So if it's going from air to glass, air to water, anything like that, it will bend towards the perpendicular or the normal. All right? When it's going the other way, okay, over here on the right, ray bends away from the normal. That's what Snell's law says. Snell's law is on your equation sheet. N1 sine theta 1 equals N2 sine theta 2. All right. So to get started with the lens thing, let's imagine we have a triangle of glass. All right. And the beam of light starting on the left, it's coming in and it hits the glass, and it hits it at a 45-degree angle to the normal, just like it's labeled here. What do we know about theta 2? Well, if it's going into glass, it bends towards the normal. So all we know is that 45 degrees has got to be greater than theta 2. We could figure out what it is from Snell's law, but the important thing is we know it bends, in this case, down a little bit. Okay. Then look when it pops out the other side of our triangle. Well, what do we know about theta 3 and theta 4? Going from a large index of refraction inside the triangle of glass to outside, we know that it's going to bend away from the normal. So theta 3 is going to be less than theta 4. Here's the important thing. Notice this light gets bent down twice as it's going through our triangle here. Okay? So what if we put two triangles like this? All right. Light coming from the right side goes in and it gets bent into the center of the lens no matter where it hits it. So if we approximate this shape with a curve, you can see that you've probably seen lenses like this. This is the classic lens that's fat in the middle and skinny on the sides. Okay? So really, a lens can be thought of as two triangles sitting on top of each other. Now they have a little curve to them, but that's kind of what they are. We can also put things together like this, in which case our lens is the opposite. It's skinny in the middle and fat on the outside. All right? And what does a lens like this do? Well, it bends light out. So the light coming in from the left is bent out. Now, real quick, important idea here. I'm going to go back a slide. What happens if light was coming from the right? can you see that exactly the same thing is going to happen? All right, the angles are going to work out such that what we're going to have is from the right or from the left, it's going to bend the light in. This one, from the right or the left, the light will be bent out. Okay, so back to our first lens. We call this kind of lens a converging lens. It's thicker in the middle. Parallel light that comes in is converged to a point, and that point is at the focal length of the lens, and it's called the focal point. Okay, so all the parallel beams. So if something's really, really, really far away and the beams are coming in essentially parallel from that object, they're going to be focused at the focal point. Now, let's do this. Let's do the same thing from the right side. If we have light coming in from the right, it gets bent to wherever that is. Let's say our focal point is right there. It goes through the focal point. All right. Notice that lenses work both directions. Can you see that? All right. Now, there's a little picture down here on the bottom. I'm sure you're curious what it is. It turns out even if the light's coming in kind of cattywampus at an angle, it is still focused, and it's focused at the focal plane. You do not need to remember that right now. All right, so I'm going to cover that back up, but I just wanted you to see that so you weren't worried I was hiding anything from you. Okay, so notice something. The lens has two focal points, one on each side. All the lenses we're going to deal with are the same shape, and so the focal points are going to be equal distances away from the lens on each side. Does it make sense? So that's the first big difference. We're going to have a focal point on each side of the lens. Moving on, if we have that lens that's fatter on the outside than the inside, we call that a diverging lens. Okay, and parallel light that goes through that gets diverged, and this one is going to get a little tricky. It gets diverged like it was diverged from the focal point going out. So this gets just a little tricky. So I'm going to put a focal point over here, way over here. That hopefully is the same distance. And if we had light that came from this side, came to the lens, then what we would do is take our dotted line up, and the light would go out like that. We'll do one more. Oh my goodness, that was terrible. There's our dotted line going back, and the light diverges out. Okay, those blue lines on the left are supposed to be going apart from each other. That was a pretty awful job. Sorry about that. Alrighty, so again, a focal point on each side, and light will go through the same way. So that was number two kinds of lenses, converging and diverging lenses. So now we got to move on to ray tracing. Okay, the rules for those three special rays that we had for mirrors changed just a teeny little bit, not very much. Let's look at number one. Rays going into the lens straight go out through the focal point. That's the same. Number two, rays going in the lens through the focal point go out straight. That one didn't change either, the wording of it. Now, it's going to take a little practice for us to get this, but we'll get it. Things change just a touch. Number three, rays going through the lens, sorry, I didn't type, through the, change this, center of the lens do not bend. That's the same as going through the radius of curvature for a mirror. Sorry about that. The center of the lens. All right, so get a bunch of space on your page. Let's do one of these. So draw a converging lens with two focal points and an object that's outside one of the focal points, kind of like this, nice and big on your paper. First ray. Okay, if you need to pause me, go ahead and do that, but I'm just going to keep on going. So the first ray goes in. Now notice what happens. Draw a dotted line down the center of the lens. The trick to doing these All we do is we ignore what happens at the front and the back side of the lens, and we pretend all the bending happens right at the center line. Now that's not quite correct, but for our ray tracing, that'll work just fine, okay? So what you do is you draw the ray coming in straight, draw it to the center of the lens, then just bend it down through the focal point. Okay? Ray number 2, draw it through the focal point first to the center of the lens, and then draw it straight out. Okay? With 2 rays, you've actually found where the object is, and the last ray, just to check, goes through the center of the lens, and it does not bend. All right? So the image in this case is inverted, and it looks like it's about the same size as the original object. Is it a real or is it a virtual image? Well, the light actually goes there. Okay? So it's a real image. Real, inverted, and it looks like the magnification is about 1. All right? How'd you do on that one? All right. This one's a tricky one. Okay? So, here we go. We are going to do a diverging lens, and I have my center of the lens drawn. I have my object and my 2 focal points. All right? Sounds good. All right, sorry about that. If there's a little hitch in the giddy up, I had to take a break for a second. So I've drawn a dim cat up on the right here, so that'll be our image when we figure out where it is. So let's begin talking about some rays. Let's do the easy one first. Let's do one that goes in straight. So we're going to draw our ray straight, and I'll try to be careful here to get to the lens, center of the lens. Now, it goes out through the focal point, but wait, the focal point on the right, the problem is the light's going to diverge. It goes out. It can't go through that focal point. So what do? Well, we've got a focal point on the left. So what we do is draw a dotted line up to there, and that is the direction the light goes. Okay? So, that was ray 1. That was the easy one. Well, one of the easy ones. The third one's easy too. Ray 2 is the toughie. Okay? So pay attention to this one. Ray 2 says, if it goes in through the focal point, it goes out straight. Well, we run into the same problem. Okay? If I go from the tail of the cat through the focal point on the left, well, that's a converging ray. It wouldn't do that. All right? So here's what we're going to do. Okay? What we're going to do is, all right, I stopped in mid-sentence there. Sorry, I had another interruption. So here's what I want to do. Let's pretend there's no cat on the left. Let's pretend there's a big cat over on the right somewhere. Okay? So I'm gonna take this little kitty and just put him up here somewhere. Let's run a ray backwards from the tip of that kitty's tail. So it goes to the left, and it looks like it's trying to go through the focal point, but what does it do? It goes out straight. So notice what happens here. For ray number 2, we say, what if it went through the focal point, but it's the focal point on the other side of the lens? The ray's trying to go through the focal point on the other side of the lens, from the right to the left, and it goes out from the right to the left straight. Okay, so here's what I'm going to do. I'm going to take a ray from the tip of the cat through, I'm sorry, let me be a little more clear here. Let me move this cat out of the way again. So we're back to the cat on the left. Let's take a ray that's trying to go through the focal point on the right. So I'm gonna try to aim for that focal point. All right, see where it tried to go? Through that focal point. Goes in that way. How does it come out? Comes out straight. And you say, golly, Wally, that doesn't help me at all. Well, Let's do our same game. Let's project that straight ray backwards. And notice it crossed the other ray. So if I shrink this cat down a bunch and bring him down here, right there is where the tip of the tail would be. Those two rays crossed right there. Let's double check this by putting a ray straight through the center of the lens. Oh, excuse me about that. We have an announcement. I don't know if you can hear that. So, boy, this lecture, I think the physics anti-heroes are winning here. I'm just having all kind of trouble. So let's, ray number 3, through the center of the lens does not bend. So I'm going to take a ray right through the middle, and I got pretty close. So notice 2 of those rays are virtual because they're backwards, and one of the rays is real. Okay? So looking at our image here, and this is the toughest one you're going to have to do, it is upright, it is smaller than the original, so its magnification is negative, and it is a virtual image, because if our eye was over here somewhere, okay, if we were here looking at it, the light is not coming from that point where we see the image of the cat. All right, it's coming from somewhere else, okay? So let's look at this a little more clearly. Here is a better drawing of what you just saw, okay? With lines a little straighter. I just wanted to walk you through that. So is something what your drawing should look like. Okay? Alrighty. Here's our 3 things. How did you do? Learn how lenses make images. They bend the light. Learn 2 different kinds of lenses, converging and diverging, and we practiced a little ray tracing. All right. Video lecture problems. Draw a ray diagram for a converging lens, but put the object between the lens and the focal point. So if we go back to an old picture, here the object is outside the focal point, and it is a converging lens. What I want you to do is draw a converging lens just like that, but put the object between the object between the focal point and the lens. Then, is the image real or imaginary, upright or inverted? Okay, so go ahead and do that. Pause me now and then see what you come up with. I'll show you the answer in just a second. All right, here's the answer. There is your ray drawing. Okay, and the answer to the second part is the image is virtual and the image is upright. Okay, hopefully that worked well. Have an awesome day. Wow, that was a long lecture. Sorry about that. Good night.